Problem 3-81. Solve each of the following inequalities for the given variable. Represent your solutions on a number line. Letter A, 5 plus 3x is less than 5. Let's go ahead and solve it by isolating x. Start out, let's subtract 5 from each side. We're going to have 3 times some value of x is going to be less than 0. Then finish isolating our x. 3 divided by 3 is going to give us 1. 1 times x is x. And 0 divided by 3 is 0. So we get x is less than 0. This is an inequality, so we're trying to represent all the possible solutions. So I need to represent x is less than 0. So I'm going to need to put 0 on my number line, and I'm going to need a few coordinates on either side of it there, just to show that our number line is facing the proper direction. So x cannot equal 0, because 0 will not make it a true statement. If we plugged in 0, and we'd have 5 plus 3 times 0 is less than 5. Well, 3 times 0 is 0, and 5 plus 0 is going to be 5. So is 5 less than 5? It's not. So that means that it is not true. So we want to make sure we put an open circle above 0 on our number line. Now we need to think about which way does the number line need to go. Do we want values that are going to be greater than 0, or do we want values that are going to be less than 0? The values that are less than 0 are going to be on our left side here. So I'm going to go ahead and put my number line to the left of 0. And I need to put an arrow because it's going to continue on that direction forever. How do I check it? Well, let's take a value that's underneath our solution here and check to make sure that it makes it true. I'm going to use -2. We have 5 plus 3 times a -2 should be less than 5. Well, 3 times -2 is -6. So we're going to have a 5 plus -6, which is going to leave us with -1. And -1 is less than 5 is a true statement, so we know we're right. We know our number line is going the correct direction. Let's look at B now. We have -3x is greater than or equal to 8 minus x. There's a couple ways this one can be done, and I'll actually show them both here. A common mistake that is made with solving inequalities is knowing when to flip our inequality. There are times, though, that you don't even have to flip your inequality. Let's take a look at that right here. If I wanted to get my variables together, I could either add an x to each side, or I could go ahead and add a 3x to each side. I'm going to add my 3x to each side right now because I want to keep it balanced. But when I add -3x and a positive 3x, these are additive inverses. It's going to leave me with 0. So I have 0 is greater than or equal to 8. And then I have -x plus 3x is going to give me a positive 2x. Now, in order to be able to solve this, I still have to get my variables by themselves, so I need to get rid of the constant term here. Now I'm going to subtract 8 from each side. I now have -8 is greater than or equal to 2x. And to get, I need to know for 1x, so I'm going to go ahead and divide each side by 2, and I'm going to have -4 is greater than or equal to x. Now, many people are more comfortable seeing the variable on the left side. So if I wanted to just reflect the entire thing over so I could see it from the other way, it would be x is less than or equal to -4. Well, let's put it on a number line here and check to see if we are correct. So I have a -4 I'm going to need a couple values on either side, so I know as I'm going to the right I'm increasing. And negative 3 is greater than negative 4. Negative 2 is greater than negative 4, so they need to be on the right. And then as we get deeper into the negatives, we actually have less. So I'll put my negative 5 and negative 6 on the left sides. Now, does negative 4 satisfy our original inequality? Let's check and see. Negative 3 times a negative 4, we're going to say that's greater than or equal to 8 minus a negative 4. Make sure you're careful plugging in all these negatives. Negative 3 times negative 4 is 12. And we're saying 12 is greater than or equal to 8 minus a negative 4 is like saying 8 plus 4, which is 12. So we get the statement 12 is greater than or equal to 12. That is a true statement because 12 does equal 12. So we know that negative 4 is a solution. So we want to put in a closed circle at negative 4. Now the rest of our inequalities that x is less than or equal to negative 4. So we want to look at all the values that are less than negative 4. So I know everything to the left is always less. So I'm going to put my arrow this side and I'm going to check it. I'm going to plug in a negative 6. Negative 3 times negative 6 is going to be greater than or equal to 8 minus a negative 6. Well, negative 3 times negative 6 is going to give us positive 18. And 8 minus negative 6 is going to give us a positive 14. 18 is greater than or equal to 14. We know we're correct there, so our number line is going the correct direction. Now I said I'd show the other way of solving B, where we actually look at flipping our inequality, so let's do that. I'm going to recopy the problem here. I'm going to do it in blue just underneath. I've got negative 3x is greater than or equal to 8 minus x. And yes, this is extra. We've already solved the problem. We've already come up with our solutions here, but we're just doing a little extra here. Now say that you chose to go ahead and add an x to each side instead of adding a 3x like we did on the problem above. We'd be at negative 2x is greater than or equal to 8. Now to get our x by itself, we need to divide by a negative 2. We divide by a negative 2. And we're going to end up with x on our left side, and we're going to end up with negative 4 on our right side. Now we already know our solution is x is less than or equal to negative 4. If I just brought my inequality straight down, we wouldn't have the same thing. We would have the opposite, which means this is the situation where we're going to actually have to take our inequality and flip it around the other way, because x is less than or equal to negative 4. We've already shown that. You can use either one of these methods to get there, but remember the thing that caused us to flip the inequality is when I divided both sides by the negative. If you multiply or divide both sides of an inequality by a negative, you have to flip your inequality as well. It's one of those rules in math that is easy to forget when you're working through a problem, so make sure you stay on top of that. This is the end of this problem. I hope this helps. If you have questions, please make sure you see your teacher in class. Otherwise, good luck and have a great evening.